was we're confused about the fact that the condensation on the outside of the can isn't actually coming through the can. So this is my not very good Coke can. I'll say it's my Diet Coke that I need to stop drinking. Okay, and so what happens is the Coke can's cold. And all this white space around it is the air around it. And this air has little droplets, even though you can't see it. It's this tiny little bits of water vapor all around in the air. Okay? Just imagine all in the air, even though you can't see it, there are these little, this water vapor. Okay? It's all in the air around us. If it wasn't, the air would feel different. It would feel drier. And certain places in the country have really dry air, and some places have really humid air. All over the world, it's different. But this is the water vapor all around it. And water vapor, when it gets cold, turns to condensation, which is water droplets. Okay? Water droplets. Okay, just listen for a minute. You don't have to write all this down. I just want you to try and understand it. So when water vapor, the little droplets in the air we can't see, can't feel, they're there. Water vapor gets cold. When it gets cold, it turns into condensation, or it condenses, which turns into these little droplets of water that you see on the outside of your can. Okay? So what happens is, nothing's coming through the can. Even if it was a cup or a styrofoam cup or anything, it's not coming through it, no matter how thin. I mean, I guess it could. If it was, paper, it might come through it. But when you get a cup at a concession stand or something, it's not coming through it. What's happening is, we know that this water vapor is going to turn into droplets of water. They're going to all come together and make droplets of water when they get colder, right? Okay? So, what happens is, the can is cold. It just came out of the fridge. It's really cold, okay? When it sits down here, this air around it starts to get colder. It's not cold enough to make this whole room colder, but it's cold enough to make the little bit of air around it colder. Does that make sense? And you can feel it. All you got to do is next time you have a cold drink, just put your hand beside it. You'll feel the cold coming off the can and making the air around it colder, okay? So what happens is when these little water vapors get colder, they start to cling, and they gather together, and they make these they condense, they make condensation, they condense together, they make the little water droplets on the side of the can.
So whenever
it comes out of the air. Yes.
Whenever it gets colder, it attracts water?
It doesn't attract water, it means that the little water, the droplets, yes, the can kind of attracts them. Okay, they attract to certain types of surfaces better than others. Yes. Yes.
Does it take a lot of them to make one drop? Or?
I don't really know. Let me show you this. Let me show you another example of this that's totally different. How many of you have taken a shower before? Hopefully you'll all raise your hands. Okay. You've taken a shower. You got it really hot. It feels good, really, really good. There's steam in the back room, right? If your mom walked in, she could see it. She could see all that water vapor in the air, right? All the steam in the air because it's all hot and steamy, right? It's because the water is very saturated. And what happens?
The mirror.
You go, wrong thing. The mirror, you go over to the mirror, and there are actually droplets. It's not just the vapor anymore. It's actually droplets of water all over the mirror, right?
It looks like fog.
Yeah. Yes. Yeah. Do you know why? Because it was in the air. Why did it go here and turn into water vapor?
Because
Ireland?
Because they're addicted to themselves.
The mirror's cold. Yeah. Have you ever put your hand on a mirror?
Yes.
It's like this board. It feels cool. That's where it collects.
And it doesn't clear off?
They always are a little. And it's something about the slick surface seems to make it attract more there. But it cools it down when it touches the mirror, and that's when they go there. Sometimes they'll even go to walls. Like the wall will be cooler. If the room gets really, really hot, your wall will be cooler than the room. And so it'll attach to the wall, and you'll see droplets running down the wall. Okay? Does that make sense?
Yes.
Okay. So that's condensation. Yes, Claire?
Doesn't the sun glare off of it instead of
That's a little different, though. there is a reflection, but that's not really what we're talking about right now. Megan?
Even if we can't feel it, does it, like in a way, affect anything else besides, does in a way kind of like affect things in this world with the water vapor? Does it affect things like if the water vapor was really effective to this book, it would kind of destroy this book?
Well, it could, yeah. If there's enough water in the air, it can destroy other things. I mean, it depends on how saturated the air is, but y'all don't have to really know all that just yet. Let's not get more complicated than we have to, since we have enough complicated stuff we've got to learn. Yes?
So, if the water is boiling in a pan, the pan gets hot though.
Yes. Yes.
And but water still drips down it, right?
Right. So you're saying if you've got a pot and you set the water to boil, you don't as much see the condensation on the outside. You see the steam, and it goes up.
And then does it stick to it? Because
Usually it sticks to something up higher. Is usually what it hides.
it goes.
But keep in mind, guys, since you understand now that it's colder, and that's what makes those droplets happen. That's the same thing in the water cycle. I feel like I'm losing a few of y'all. I hope you really understand the water cycle. So this is my ocean. This is the sun beating down on the ocean, warming this up. So this water, it's a cycle, so it repeats itself. So the ocean, the sun's heating the ocean up, and when it heats up the ocean up, the water evaporates, just like the water in your hot tub evaporated when it got too warm. So it heats up, it goes up in the air because it's in the water vapor, and some of that water vapor rises on up. But when it gets up here, we all know it's colder the higher you go. Have you ever hiked in a mountain before? It's colder up there. Even in the summer, it's colder. Sometimes there's even snow on the ground in the summer because it's colder up there. So if you go even higher, way up in the sky, it's even colder. So when the water droplets keep going up and up and up and up and up, they start getting to the point where they're cold enough, they start to turn back into water. And they don't just turn into water and fall back to the sky. They gather together with other water droplets. Okay? So they gather together with other water droplets. Usually some dust is in the air too. They all gather together and they make clouds. Okay? And then the clouds get really, really full because a lot of water vapors come up. They've gotten cooler up here. They've turned into water droplets just like on the Coke can and on your mirror. And then it starts to rain. And what is the big fancy word that we call the rain that comes down? Ella. Precipitation. Condensation, not obtained. Condensation, evaporation, and precipitation. Hopefully I spelled that right. And precipitation, those are the main words you need to understand. Evaporation, it turns into water vapor and moves up in the air. Condensation, they all gather back together and turn back, the water vapor turns back into water droplets. And precipitation, it's rain, sleet, snow falling from the sky, wet stuff. Got it?
Hail?
Hail, yes, precipitation. Okay, you can cut us off, Adam. Okay, now, you do